From IBM's Expert Labs group, and I'm going to show you how to use this Python utility to transcribe a series of audio files into text, as well as to measure the accuracy of that transcription. Let's start by taking a look at our audio files. So I've created a directory called rhymes, and there's 4 files in this directory. These are the 4 lines of a children's nursery rhyme, Hey Diddle Diddle, the Cat and the Fiddle. And I've recorded each of the lines of the rhyme into a single file. So there's 4 lines in the rhyme and there's 4 total files. And what I'm going to do is I'm going to use the Python utility to transcribe these files into text and then later to assess the accuracy of that transcription. So let's first look at how we configure the tool to do the transcription. So there is a configuration file, and the very first section is dedicated to how do we connect to speech-to-text. If you're using the cloud instance of speech-to-text, you only have to worry about the first 2 lines, your API key and your service URL. The third line is for those of us who are running on Cloud Pak for data. But once you've got the API key and the service URL, you'll be able to connect to speech-to-text. And then we look at the next 4 lines to configure how we're going to do the transcription. So in my case, I'm just going to use the base model. The ENUS narrowband model is the US English model that's used for telephone models. If I had a custom model, I could supply the parameters for the language model or the acoustic model here. In my case, I don't. I'm just using the base model. And then we need to tell the tool a little bit about the audio files and where the input and output data is going to be located. So in this section, you can see I've told it that the audio files are going to be located in a folder called rhymes. Once it transcribes the files, I want it to put the transcriptions into a file called rhymetranscriptions.csv. And I'm going to put the actual text of these files into a separate file called rhyme reference. So I'm going to have in this first file what the model says the right answer is, and in the second file I'm going to have what the actual answer is. I'm going to use that to compare the model's transcription to the right one and find out what the accuracy is. Now at this point, neither of those 2 CSV files exist. We're going to create them with the tool. There's several other parameters that exist in this file, but for most cases, the defaults are going to be fine. So let's start by running a transcription of our audio files. So I'm going to run the TRANSCRIBE.py script. I'm going to pass it my configuration file. And we'll see here that it's starting to transcribe the audio files. This will take it just a couple of seconds, but what it's going to do is go through each of those 4 files, and then it's going to create a CSV file where every row of the CSV corresponds to one of these audio files, and there's going to be 2 columns, one for the file name and one for the actual transcription. So we can see that the transcription is finished, and we can take a look at that file right now. So we can see, again, there's 2 columns. We've got the file name, and then we've got the transcription for each of these. So this is great. This is a really easy way for us to get started transcribing some files. But we don't yet know if those transcriptions are right. So what I'm going to do is I'm going to close this file, and we're going to create a file for the actual transcriptions. But what I'm going to do is I'm going to use that other file as a starting point. So I'm going to create that reference file. And I'm going to copy the model's answer, and I'm going to create a column called reference. And I know these transcriptions aren't all correct, but it's going to be easier for me to correct the model's transcriptions rather than to type in the entire answer myself. So there's only 4 files here. Let's go through the exercise and let's listen to each of these and see if the model got them right. So my first file.
Hey diddle diddle, the cat and the fiddle.
All right, so in this one, the transcription was perfect. Let's move on to the second one.
The cow jumped over the moon.
Okay, here we saw there was a mistake. It should say the cow jumped over the moon. We'll keep going to the third one.
The little dog laughed to see such sport.
All right, that one was correct.
And the dish ran away with the spoon.
Okay, so now we've got the actual transcription, or the actual answer in this reference column, and we've got the model's transcription in the transcription column. So since it's only 4 files, we could eyeball it, but I want to demonstrate how the tool can do the accuracy assessment automatically. So I'm going to close this file, and I'm going to run our analysis script, and I'm going to pass it the same configuration file. You can see it ran pretty quickly. Again, with only 4 files, it doesn't take very long. Let's take a look at the errors that it found. So we can see here we've got a lot more data now, and we've got the same columns that we provided before, but now we see some interesting metrics here. We see a word error rate column and an information loss column and a couple other columns as well. And what this is doing is giving us pretty detailed data on what happened, on how well the model performed. So if we take this first transcription, which we noted before was accurate, we noted it didn't make any mistakes, so there's no word error rate, there's no information loss. There were 8 total words, and it got them all right, so there's 8 hits. But you'll recall in the second example, we did have to do some changes, right? So the reference was the cow jumped over the moon. The transcription was that cow jumped over the moon. So there were 2 errors in that. So you can see there's 4 hits because we got 4 of the words correct, and there's 2 substitutions, meaning there were we switched the for that and cow for cal. So you can see that reflected in the 33% word error rate. And you can also see in this last column that it's calling out the specific words we got wrong. And even though we technically got 2 words wrong with the and cow, really the important word that we got wrong is cow. So it's called out here. Stop words or less important words like the and aren't necessarily going to be mentioned here. But we can use this differences column to see if there's any patterns in the words that we're getting wrong. So this is just a brief overview of the low-level details we get from this report. Let's also look at the high-level summary that was provided. So here, this is, instead of giving us a line by line, we're going to get an overview of the entire thing. So it's telling us there was 4 examples. Within those examples, there were 34 words and 2 errors. So at a very high level, we got about 5% word error rate on our entire selection. And we also found out that of the samples, there was which had 4 sentences, we got 1 sentence wrong. So our sentence error rate was 0.25 or 25%. So I hope this demonstration shows you at a high level how this tool can work. In a typical project, you're going to have a lot more audio files, and being able to automate this transcription analysis is much more helpful. In a typical process, what you would do for a project, you would have your audio files. You would use this tool to create the initial transcription like we did before. You would, from that transcription, you could bootstrap your actual reference transcription so that you don't have to listen to the entire thing. It's easier for you to correct the mistakes in the transcription when you're creating your golden reference. You can run a comparison between the actual transcription and what the model gave you. And you can use that insight to train or improve a model. And once you've changed the model, you can start the cycle over again. And essentially, you keep running this cycle until you are satisfied with the results of your speech model. So thank you for your time for listening to this video.